Hello everyone. In this series, we will be seeing how we can have event-driven implementation on AWS. There are many services available in AWS which can be very much overwhelming on when to use what, why and when. So in this first video, we will be seeing about 3 different services that are available on AWS which will help us decouple our applications. We will be looking into SQS, SNS and Event Bridge in detail. First, let us look at SQS. SQS stands for Simple Queue Service. It is a 1:1 reliable asynchronous communication service, which means that for a message that is produced, there will be one reliable consumer. So this is basically used when we need one-to-one kind of a communication. Second, it will help us decouple our application. There are 3 main parts that we need to be aware when it comes to SQS. The first one is the message. Message is nothing but a blob. It could be a raw JSON or it could be anything which has certain limits that a producer or any service can send to someone else. All these messages get sent to a temporary pool which we call as a queue. Now this queue can either be ordered or it may be unordered. By default, the default configuration is to be not guaranteeing the order, and that has a pretty much high throughput. If anyone requests or needs first in first out kind of a scenario, then it comes at a limitation of around 1000 requests per second. But in the default configuration where the order is not guaranteed, you could have unlimited messages per second. The last part or the last important parameter is the polling. So basically, in order to consume a message, one service needs to poll. So let us see how this looks in action, right? So basically, we will have a producer. Let's say that is a service 1. The service 1 sends in a message to a queue. The messages stays in this queue till we have a consumer or any other service that polls in that queue. Once the service polls in that queue, the messages will be consumed and can be processed. Once the messages are processed, it is acknowledged and the message is removed from this queue. As I mentioned previously, order is not guaranteed unless specified. So let's say we have an order service. For that, we will have an SQS queue, namely order queue, and we will have a consumer, in this case, a Lambda function. When we want to send any event from the order service, we send a send message to the order queue, that is the SQS, and all these messages stays on the order queue until we have a consumer that is polling on this queue. So let's say we use a Lambda which will act as a consumer who will be polling for the messages on this order queue. Once you associate a Lambda with the SQS, the messages are automatically polled. That is, you don't need to write explicit logic in order to poll a given message. This is available by default with Lambda, but in case you write your services in, let's say, EC2 service or an Fargate service, then you would need to write a logic in order to poll the message from this SQS queue. So once the Lambda starts polling, these messages will be consumed and then processed accordingly. Okay, so this is in nutshell SQS. Keep in mind, it is used for one-to-one reliable asynchronous service and basically allows us to decouple our business application stuff. The next one that we would be seeing is SNS. As the name says, it is simple notification service. The major difference of SNS over SQS is that it allows one-to-many kind of a communication, which we call as fan out. That is, one publisher just takes that message and fans it out to all the different consumers who are interested. With this, it provides us an high throughput and allows to have many subscribers, which was not possible in SQS as it was 1:1. This is an ideal service, especially when building a scalable enterprise applications. So most of the time, when you want to architect any enterprise scale applications, you would possibly use SNS to build a scalable one. Here, you need to be aware about 4 important parameters. One is the message itself. Instead of queue, here we would be having a topic. Now the topic allows us to fan out to multiple subscribers as opposed to a queue. And the mechanism through which this works is publish subscribe as opposed to polling in SQS. So let's say we have a service one, which would be a publisher. It sends a message to the topic. Now the messages remain on these topics even though there are consumers who consume it. Now let's say we send a message to the topic. We can have n number of subscribers or services that subscribe to this topic, which will receive a copy of this message, which can be then processed. Even once these services or consumers consume this message, the message will remain on this topic for a definite amount of time that is configured. So to see in example, let's say we have an order service. We have different consumers. In this case, we have 2 consumers, which are Lambda functions. We have an order topic. The order service publishes a message to the order topic. Okay, and then we could have these consumers who subscribe to this topic, and these messages will be made available to both these applications. That is, we are fanning out the messages. We are passing on a copy of that message to each of these consumers, and accordingly this will be consumed by this application, and finally after a predefined amount of time the messages will be removed from the topic. Okay, the last one that we will be seeing is the Event Bridge. Event Bridge is the latest service from AWS. It allows again to have one-to-many kind of a communication, but the many here is restricted to 5. So we will see this in detail what it means. It also allows us to filter messages, define rules, so that we can, based on the parameters or the conditions within the incoming message, we can decide what should be the destination target for that message. This is very much suitable, especially when you want to have application integrations in case of SaaS-based application. For example, MongoDB Atlas. Let's say you are using MongoDB Atlas, and based on certain insertions or any data manipulations that happen at the MongoDB Atlas, you want to be notified and process any business logic on your AWS side, then Event Bridge provides those kind of partner integrations. Here, we need to be aware about 4 important parts. One is the message bus, events, rules, and targets. By default, there is a default message bus that is configured within Event Bridge. It's always recommended that you create your own message bus. Let's say if you are concerned about orders, then you create an order bus. The messages that each service sends are known as events here. On these events, you can define rules. The rules can define exactly based on what parameters within your incoming message you want to send it to the targets. Now the targets can be 5 maximum for each rule, and those targets can be AWS services like SQS, SNS, Lambda, and so on. So there is a list of targets that Event Bridge supports, and same can be found in the AWS documentation. So this is how it looks. We have an order service which publishes a message onto the order bus. This messages, also known as events, will be evaluated by the rules that are configured on this bus. Based on the rules, those are then sent or distributed to the respective targets. Like for example, here we see that this rule is sending those messages to Kinesis Firehose, Lambda, SNS, and for that SNS then we have multiple subscribers or consumers. Similarly, the second rule sends the message based on the correct evaluation. It will send it to the SQS, which is then consumed by the consumer, that is Lambda in this case. Okay, so basically these are the 3 services that are available in AWS, which one would use for decoupling of applications and to build an enterprise-ready scalable ecosystem. So that's all I wanted to cover in this video. I will see you in the next one. Until then, happy learning.